In this question, we're to determine the height of the totem pole to the nearest meter. Now, because the question was done with a whole bunch of estimations, it makes sense that we wouldn't want the height to the nearest tenth of a meter because we're just estimating. So what do we need to find out? Well, in order to do this question, we need to simplify it. And what we really want to do is only look at this blue triangle. We need to find the angles of that triangle so that we can solve for h. We already know that one side is 42 meters. So we need to know more information before we can solve the problem. So the first thing we're going to find is angle BDC. Now, that angle can be written as BDC or CDB. Either way is the same angle. So to find that angle, all we have to do is know that that angle and this angle together, add together to give you 180 degrees. They're supplementary. So how do we find that out? Well, we actually have another triangle, and that's this red triangle. We're told that this tiny little angle in here is 5 degrees. And this angle is 40 degrees. So if that's true, we know that the sum of the angles in any triangle is 180 degrees. So doing some simple math, we just subtract 40 and 5 and we get 135 degrees. Now again, that's for this angle right here. So if that's true, then it automatically means that the angle here at BDC would be 45 degrees because it has to add up together to give you 180 degrees. So now we know a couple of things. We know that this angle is 45 degrees. We know that this side is 42 meters, and we want to find out what this height is. So we already have a side angle, a side opposite angle relationship. So if we know this side over here, we can use the law of sines. So we have CBD. CBD is this angle right here. Now we're told earlier that the totem pole is standing straight up, which means it makes an angle of 90 degrees with the horizontal. And we're told that this angle right here is 5. So quite simply, we can find out what that angle is by subtracting 5 from 90. So that would be 85 degrees. Then the angle at DCB, that's this one. We can find that because we know now that this one is 85, and we just subtract 45 and 85 from 180 to get 50 degrees. And now we know everything we need to do to finish this question off. So our job here was to simplify the problem to get just a simple triangle. We have a triangle that we know all three angles of and one side, and we can use the law of sines because we have the angle and the opposite side relationships. Now because I'm trying to find the side, I would put h over the sine of the angle that it's opposite from, so that would be 45 degrees. And that is equal to the side that I know, which is 42 meters, divided by the angle across from it, the sine of the angle across from it, which is 50 degrees. Now again, I know that because h is across from a smaller angle, that my answer should be less than 42 degrees. So doing the math, I'll have h equals 42 times the sine of 45 degrees, and I divide that by the sine of 50 degrees, and I'll end up with h equals 38.77 meters. But remember when I talked about this at the beginning, I said we wanted it to the nearest meter. Because we made a lot of approximations, again, it doesn't make sense to have our answer to the nearest centimeter. So that means we want to round it off to the nearest meter, which is 39 meters. So the totem pole is 39 meters high.